Hey folks, CircuitPython Day is August 6th, 2021, and it's the snakiest day of the year. This day highlights all things CircuitPython and Python on hardware. Tag your projects on social media to have them showcased on CircuitPython Day. CircuitPython is an easy-to-use programming language for microcontrollers. You can install CircuitPython on a lot of different boards from Adafruit and the community. The libraries and code live on the board, so it's way more accessible. The board shows up like a USB drive, so you can just drag and drop a UF2 file. It automatically installs the firmware, so it's really easy to upgrade to future releases. This makes iteration much faster, so you don't have to compile your code like in Arduino. It works like a USB storage device, so you can drag and drop files right on the drive. Bundlefly will grab all of the code and libraries, but also any project files like fonts and images. All of the files are bundled in a single zip, so you'll have everything you need to run the code. We think this makes maintaining code much better, and it's just awesome for beginners. For all things CircuitPython related, check out the links in the awesome list. You can listen to podcasts, chat on the Discord server, and subscribe to the newsletter. So go to circuitpython.org and get your projects up and running.
Welcome to the board tour with Ladyada.
Hey everybody, hey, it's me, Ladyada, with me, Mr. Ladyada.
Hello.
It's CircuitPython Day. The factory is very quiet today because we gave a lot of people the day off. Well, there's a couple people still working today.
It's a float holiday, as they say in the employment biz,
which they like because it means that people who want to take the day off can, or they work today, they take another day off. They get an extra day whenever they want.
Yeah,
so you might see some people.
We made it a company holiday.
Yeah. But we're here at the Adafruit factory. We're celebrating, I think, our third CircuitPython Day, the snakiest day of the year. It's cool. It's always been a remote-only event, and
well, we did in-person events one of the first years.
Last 2 years, obviously not.
Yeah, and what we decided to do is, well, we could try to do something in person, but it would be pretty tough because there's a lot of uncertainties, especially even right now. And so we said, well, let's continue to do what we've always really been able to do, which is online shows, online content, and virtual so you can watch it anytime.
Okay.
And this one, we wanted to do this style of video for a while. And we're calling it the board tour.
Board tour.
Where you're not going to be bored.
Not going to be bored.
Yeah.
And we're not boring into rock. And it's about boards.
The reason why we're doing a board tour is we get asked this a lot, and I have good news and bad news. Good news, you're going to get a board tour from Ladyada and talk about a lot of CircuitPython boards. Bad news, or just other news, is we'll never be able to do a comprehensive guide that's up to date, that covers everything we'd want to.
Because there's so many
that would cover our stuff. Yeah. And I wouldn't feel right unless we said, well, there's other boards besides Adafruit.
That said, DigiKey and Meg have a great board.
So let's start.
Comparison.
Let's start with that.
Okay.
Because I want to give shout outs, and I used to work at Meg, so
okay. So check this.
So this right now is magazine.com/comparison/boards, and this is the best board guide available right now. You can type Adafruit, and you can see a lot of boards. It doesn't have the most recent latest thing,
but it has a lot of the popular ones.
But it has everything up until like September of 2020. Yeah. And that's we make quite a bit of boards. So if you wanted to go in and let's say, so I had the filter for Adafruit, but let's say if you just wanted to see SparkFun boards, SparkFun, their boards support CircuitPython, at least some of them do, and you'll be able to see
it's
Spark dash fun. So
auto complete. Okay.
So you could see their other boards, and they've moved towards the Thing Plus form factor
and MicroMod.
But
they also have like their Arduino type shape.
Yeah. So depending on which one you choose, you'll be able to run a version of Python, or specifically CircuitPython. And I saw in their forums that folks wanted to get CircuitPython on their MicroMod, and now they have a VID-PID, which allows you to name it so computers recognize it and all that stuff. So this is all good news. So I really want to stress one thing, because I don't think anyone else talks like that. So one of the reasons we're never going to do a board guide, because I would say we should cover all the boards that Adafruit doesn't make too.
Yes.
And that just means it's now thousands and thousands of boards every year.
Which
It'll
is why
never
it's
be
good to have an
updated.
independent group like Make and DigiKey, who they don't make these boards; they're just
'cause
covering them.
I know for a fact we're not going to have every board for everyone. And as we talk about the board tour, most of the boards, in fact, the most popular board that runs CircuitPython is not from Adafruit. So our board guide, the board tour, is going to be specifically for boards that we know that work with CircuitPython. But just so I can send a link to folks in the future. It's like, we'll never be able to do a better job than what Make's doing with this. So I'd rather just help Make, support Make, work with DigiKey, and whoever's doing the biggest, most comprehensive board guide, let's have them do that so everything's in there. Because like anytime you see a board guide from a company, they're just going to put their own things in it. And CircuitPython is a different thing than Adafruit. And so we have lots of different boards, but this is solely focused on CircuitPython boards. But for all boards, and you care like if you want to just sort by clock speed, or if it has Ethernet, like Make has a good resource for that. So
okay, so check that out too.
Yeah. Adding to that, if you get the Make guide to boards, the 2020 board guide with DigiKey has this like AR thing. So when you look at the magazine, or when you look at the like PDF or whatever, or you could just download the app, you can look at the boards in AR.
Yeah.
Augmented reality.
Which is cool because you can see it in like physical, how big it is, how it looks, like twisted around.
And we're going to we'll answer any questions as we go through this with the with boards. But I wanted to give everyone, like, here's where we're starting. So go to circuitpython.org. And this is your first stop. Pretty much anything you want to do or know about, or if anyone has any questions about it or how it's related to MicroPython, everything is on here on this page. And so sometimes folks ask questions, we're like, it's all right there, it's all right there, it's all right there. But this is the first stop, circuitpython.org. Next up, let's go to the downloads. And this is what I was saying before. It's unusual, I think, for an entity to embrace all of the possibilities. So the number one board that runs CircuitPython right now is Pico.
Yeah, this is sorted by downloads. Although I will
say we could do it other ways too.
It isn't all the downloads, especially when we just have a new release. It'll be a little bit, not organized until we, because it takes a while to get all that download data and parse it. But it is a rough. It's a rough estimate of the number of downloads, which is a proxy for us of popularity. And the Pico is an incredibly popular board from Raspberry Pi. I actually think the Pico is a particularly interesting board and chipset. The RP2040 and the Pico is the dev board for it because, I don't have any personal insight into the inner workings of the Raspberry Pi Foundation or development group, but it really felt like they designed this chip specifically to run Python on hardware. Like this is a chip that when I look at it, I'm like, wow, this is extremely high RAM, the dual core, the PIO, peripheral. This is really a great, built-in UF2 bootloader. This is great for running and installing CircuitPython or MicroPython, which is their official distribution for Python hardware. And so I think it's interesting that we've moved from here's a board that's like, we've made boards and some of them are designed for CircuitPython or they're boards designed for MicroPython, because we have external flash memory on them or like a NeoPixel indicator. But this is really neat because this is the first chip, silicon hardware, that it's designed with running Python on hardware in mind. And this is a big twist in how you think about hardware and the software that runs on hardware because oftentimes silicon developers will design hardware specifically for running Linux. That's not unusual. They're like, what are the requirements I'm going to need to be able to run Linux on this? And obviously they think a lot about, running C compiled program. How does GCC compile for this chip and kind of optimizing the caches and, the memory layouts and stuff so that a C compiler works well with it. And it's neat that this is now designed specifically for Python on hardware and other interpreted languages. So very, very interesting, right? It's taking a while for Python on hardware to become popular, but it's quite a sign for me to see this. And hopefully other chip makers will take advantage of seeing the popularity of the RP2040 and make more chips with a large amount of RAM. That's the thing that really helps a board be good.
RAM and USB. right? Like,
native USB, honestly, almost every chip has native USB, thankfully. Although I wish they would add support to TinyUSB for us. I think it would be cool if they did the pull request to add that support. But the built-in USB bootloader and 264K of RAM, I mean, I love it. I'm getting all fluffy.
Okay, so that's the most. When we have the next version, the download count will get updated. But that's the most downloads of CircuitPython for a board right now.
Yeah.
Okay, great.
Number one.
So I want to go through just the top ones, and maybe we could talk about
and then we can talk about those.
And then what I want to also do is, so folks are like, oh, I wish I had a filter based on like features or like whatever.
There's filters.
You just have to hit click filters.
Click filter.
So you can always do that. Like if you're like, I really want Wi-Fi, you can go and click Wi-Fi, and then you're looking at boards with just Wi-Fi.
Yeah.
And again, like not necessarily just from Adafruit. In fact, in the top 3, only one's from Adafruit. So let's now go to Circuit Playground Express. The original, I'd say.
This is actually one of the first boards that was designed specifically. Again, the chip wasn't designed for CircuitPython, but the board was. And the real thing that made a difference was the inclusion of that onboard flash chip. I got to give a shout out to Scott Tan-Newt. We were thinking like, how are we going to add more storage so we could store like, files and any assets for programming. And I think he was like, we're thinking like, oh, should there be an SD card? Because the Pi board had an SD card. And I think he mentioned, well, could we have some sort of external flash chip, like some memory chip? And I was like, oh yeah, we could do that. The flash chip, you see it between the main microcontroller and the USB port. These are only 30 cents, and, 30 cents to $1. And it really changed, how we interface with the software, because we wanted to make sure that, that we had this board and we had all this hardware on it. We wanted to make sure that people could drag and drop files very easily, because the biggest challenge that we found with Arduino was people not understanding how to install the IDE. This is where the Circuit Playground came from, is teachers saying, we have Chromebooks, there's no IDE. At the time, there was no web-based Arduino IDE. They were like, we want NeoPixels, we want sensors, but we don't want any soldering. We want to be able to alligator clip stuff on. And so this is where the CircuitPython.
Let me even break it down more for folks. So we were at a really big, New York City has some of the biggest school systems in the country. We're at an event with teachers, and they described what they wanted. They said, we want something under $20. It has to work on really old Windows machines.
7.
It might not have internet sometimes. Oh, also Chromebooks. Also, we're using Python. We need to teach Python, and it needs to have a bunch of sensors. And it also should have some type of block language. And we used to do some Arduino stuff, but we're moving to Python. So can you just do all that? And can it be $20? And we're like, yeah. And so one other piece of this is Circuit Playground Express in particular. You can do lots of different things with this. So today is about CircuitPython Day, but you can do Arduino, you can do MakeCode, you can do CircuitPython, you can do Rust, you can do TinyGo. It really is like the universal.
And the SAMD21 it's a lovely chip.
You can write your name on the back.
I will say the SAMD21, even with the Express, it's at this point, you can definitely run CircuitPython on it. It's great for beginners, but people will very quickly run out of memory. They'll find it, a little limited. I don't think that's a problem. I think for a lot of beginners, what we think of as like, okay, I want to do an advanced program with a Circuit Playground Express. You can always, of course, use Arduino or TinyGo or Rust, which are not nearly as memory intensive. But for a lot of beginners, pressing a button, making a sound, shaking it, and the LEDs sparkle, this is a really big step for them in learning electronics, to have really just an if statement. I mean, it's massive to have someone learn an if statement. It's a very core part of programming, and procedural programming, one step after the other. And the Circuit Playground Express can do that very well, because there's so many, things you can do, press buttons, and there's audio input, and there's a switch, and there's accelerometer, and LEDs, and buttons, and buzzers, and sensors, and capacitive touch. So this is kind of an all-in-one board. It doesn't have everything, but you can watch our Maker to Market series that we did with DigiKey if you want to learn a little bit more of how I designed this and why I designed it this way. It was it's an offshoot of the Flora wanted to just try to cram as much stuff in there as possible.
Yeah, so check that out here. And so that's the second most popular board.
Okay.
And then third one.
Okay, so the Arduino Xiao. This is a really popular board. I really love this file, this format. So I've used it in our Quie Pie format. We added a little add-on, but this is sort of like mini USB-C. It's a little bit more pins than a Trinket, but it's really tiny. And it's just got like 10 GPIO pins and power, and it's got little SMT pads. Really cute. I really like this. I like the tin on it.
Well, I was going to say, so why does this one have a tin? Why do you think there's a tin on it?
I think it's to protect it, so you can put it into projects without having to worry about exposure. I mean, it's not an RF thing. You don't need that. There's no RF. There's no Wi-Fi or radio on this chip. Again, this is a SAMD21. This one, again, you're going to be able to do some basic projects, not super big, complicated ones, but you can get, LEDs and touch and inputs and outputs and maybe like a small LCD display or something. And of course, all these boards run Arduino as well. So it's like you can have both. Only thing about this one is it doesn't have the external flash chip on it like the Express boards do. So you only have about 30K of memory. So this won't be able to play audio clips or anything. You can make tones, but it can't store files.
All right. So third most popular. And then rounding out just the
I think we just kind of go through these. So the Trinket M0 and the Feather. The Trinket M0 is actually kind of a predecessor to the Xiao. Again, it's got a couple pins. It's small. People like the Trinket. Originally, this was an ATtiny 85 board, the original Trinket. Wow. But what's nice is that, with a little bit of noodling, we fit a SAMD21 E18 on it. Again, doesn't have external flash memory, so it doesn't have a lot of space. But if you want something small and thin and cheap, this will do the job. There's a little NeoPixel dot star on there. Regulator has, 5 GPIO, including, PWMs and analog inputs. As in like a little RGB, a little red LED and a green power LED and a reset button, and mounting holes. So, nice, a cutie.
Just because the chat will always be a couple minutes different. Folks like the Adafruit CircuitPython library, great too, was playing with it for the first time last night. Amazing how much functionality fits into a tiny memory.
Yeah, I mean, there is a lot of, we work very hard to make, yes, it is an interpreted language. It's going to be 10 times slower. We think the benefits are worth it, but more importantly, we know that chips are getting faster and better. The RP2040 now, the price is out $1 a piece. It's much cheaper than the SAMD21. We're not going to go and discontinue our existing boards, but you're going to see a lot more boards come out with better. There's going to be a slow improvement in the capabilities of chips as the prices come down, the capabilities move up. When we started the Trinket, the original Trinket, 8 years ago, it was an ATtiny 85, like literally 256 bytes of RAM or something ridiculous. But at the time it was like, oh, this is cool. It's so cheap. It's so easy to use. But then, bumping that up to an RP2040, it's the same. The chip is the same price. It's about $1 a piece. All right, so let's go through.
Yeah, let's keep going. So
the next group we've got, so we'll do these 4 at a time. We've got the M4 series. So you see the Feather RP2040. It's just a Feather form factor of the RP2040, a great CircuitPython chip. The M4 is really one of my favorite chips. Tragically, it's been hit very hard by the silicon shortage. We're trying desperately to get chips, but just so you know, it's one of the chips that we've booked many orders and they keep pushed.
So on the board tour, anything with which chips?
M4s, SAMD51s, the M4 chips are, and the NRF52840s a little bit. RP2040 does not seem to be affected, and the ESP32s don't seem to be affected. But
so if someone's playing on a board, maybe double check the supply for those before you commit to it.
The SAMD21 is actually also quite hard to get. However, we use so many of them that we have like a year's worth of stock because we just go through so many that we book many in advance. So the SAMD series was really hit hard. The MagTag is interesting because this is our first, it was an AdaBox board with an e-ink display and an ESP32 S2. And the ESP32 S2 is the first espressive chip that is Wi-Fi, because that's espressive's specialty, and native USB. And that native USB, because we really demand that our boards have a good workflow. We didn't want to, we actually used to support ESP32, 8266, and we dropped that support because it was so hard to get files on and off the board that when the S2 came out, it's the same price as the ESP32, but has USB. So we were able to do this cool ultra low power Wi-Fi e-ink display. This is one of my favorite boards. We still have this on our fridge.
Yeah, so this board, we've updated our CircuitPython projects on it and our home fridges. We have the number of vax in the US, and then we have the number, so then we have the weather.
Yeah.
And we have 2 of them. And it's like, you just glance at it every day and it runs for months.
No, it's great. As I knew as I got, it's going to be a great weather day. Tomorrow might be a little rainy.
Yeah, the vaccinations are a little bit more encouraging than the COVID tracker.
Yeah, but for the experience, if you're like, I really want a good, powerful board, the Feather M4 and the ESP32 S2 and the RP2040 are like top notch. The M4, I think, is the fastest chip we have, like fully featured fastest chip, even though technically I think the ESP32 S2 has higher megahertz because of the way it does the cache execution. I think the M4 is really the fastest. And the Teensy boards are technically faster, but we don't have full support for them.
Yeah.
Okay. So
we still have these. We do have a limit on them, 2 per customer. And then one last thing on MagTag. So if you have Wi-Fi, one of the challenges is like, well, I need a data service, and I want to make sure like my privacy is respected, and like the data service is not going to go down, and it needs to be easy and all that stuff. So that's why we have Adafruit IO free for most things you need. And if you need to plug it into something, and you can do anything you want on Adafruit IO. We don't lock it down to specific devices, only from Adafruit. What's next?
Okay, so we got the Matrix Portal. This is a board that has an M4, again, one of our favorite chips, and then an ESP32 is a coprocessor. And it lets you do, you can see when this was shot. This was during the time when people were wearing a lot of gloves and
back
PPE.
when COVID was a thing. Oh, sorry.
Yeah. Well, it's moved from hands to Vax and Max and Mask. But this is what I thought would be neat is to make a board that makes it really, really easy to drive these RGB LED matrix displays. They're usually quite difficult to use, but having something that would make it easy to plug Wi-Fi in.
Okay. And you can check out some of the other. Some more. All right, so that's that board. All right. Next up.
Okay, so next up we've got, so you see a lot of RP2040 stuff filtering to the top. Arduino, they've got the Nano RP2040 Connect. This one is neat because it's got the RP2040 as a main chip, and again, an ESP32 as a coprocessor. In fact, Arduino is who came up with the whole idea of having a coprocessor chip. They did such a good job that we borrowed their code. We made a couple changes to it. And then they also have tons of sensors on this. So it's good for machine learning as well as doing Wi-Fi projects. And you can use this with CircuitPython and do the Wi-Fi and do the sensors. I think we got everything working with it.
What's neat
it's interesting. This is the first Arduino board with the RP2040, and it's got great Python and hardware support.
Yeah. And that's neat is if you see an RP2040, you know CircuitPython is probably going to be running on it. Yeah. Or at least can. Okay, next up.
Funhouse, that was our last AdaBox board. So it's kind of it's just designed for it's an ESP32 S2, and we wanted to do something that was specifically for home automation projects. We're still hoping to get first class support in Home Assistant for this, but the ESP32 S2 is still not out of beta yet. Espressive likes to keep their chips in beta for quite a while. That said, it's got a pack full of sensors and Wi-Fi and a TFT display. So if you want to do home automation projects, sensor inputs, and sending them to Adafruit IO, this board is the place. I really like the ESP32 S2, and I feel like we've really gotten significantly better with it. And it's got a ton of sensors built in. I always like to have, I like to have kind of 2 types of boards, either tons of stuff built in or like nothing built in.
Yeah.
We also, last year, this is the first NRF52840 board. This is Bluetooth Low Energy. The Nordic chipset's ultra low power capable and has BLE support. And we worked really hard to give CircuitPython really good native BLE, both peripheral and host support. So it can talk to peripherals, it can also act like a peripheral. And I think in our libraries, even you can, like our libraries kind of work either way. You can just, depending on how you initialize the object, it can be one or the other. And another thing that I thought was, we're doing more Bluetooth Low Energy, and we've actually started adding, Scott's working on Bluetooth Low Energy only workflow. So like, what if you wanted to program boards that didn't have USB, or maybe you just wanted to program them wirelessly? A lot of people have, mobile phones as their only computational device. They don't have a laptop necessarily, or maybe they can't install software on the laptop, or it's really locked down. But Web Bluetooth, which is available in Chrome OS and in Chrome browsers, can transfer files, can interface with the REPL. So we've started that process. So it could be an interesting way to get devices that don't have native USB, or we were thinking, what if, smartwatches, they're often running an NRF52 chip, but you don't necessarily have a USB port. So it's like, how do you install software? They're expecting you to use over the air only. So this would be over the air only programming.
For the folks who've been following along on PyLeap, which is our code editor for CircuitPython, you'll see that we started off with the Bluefruit Express is the board.
Because it's a little, it's like the Circuit Playground Express, but with Bluetooth. Okay, we've got the Quie Pie. This is our kind of Xiao-alike board. It's the same pinout, but what we really like about this board is that we put a Stemma QT connector on it, and so you can plug in all of our sensors, and almost every sensor we have has I2C that has I2C, it has CircuitPython support. So being able to plug, and you can also solder a chip on the bottom if you want more memory, but being able to plug in Stemma QT is part of it. Many years ago, we talked to Chris Anderson, the good one, and he mentioned what? He mentioned, the future is solderless.
From Earth Prime.
Yeah.
Earth Prime,
no,
Chris
Earth
Anderson.
Prime is the evil one.
Okay.
All right. Chris Anderson is from Earth. And you said like we have to get to a point where we're not soldering, and so Stemma QT, which is also quick or ZIO format. A lot of companies have migrated to it. Yeah. Grove similar. Plug and play is part of it. If you can have plug and play software, plug and play hardware, it just takes a lot of time to, get everything converted over and sort of naturally. There's no open hardware commission where it's like the IEEE where we all agree on standards. We have a system where the market is the standard.
Pretty much.
So Feather becomes popular, and then SparkFun's like, okay, we're going to do Thing Plus. It's a variant of Feather, but it sticks to that standard. But we didn't all talk to each other and agree on it. We just sort of all look at what's working out.
I would say it would be great if everyone got together, and we've tried. But
I actually think this is maybe a little bit more healthy, because it means that even if you don't have a seat at the table, you can come up with ideas and just have it sort of like, battle out in the market.
So I'll say it is. That is one way. But we had talked to Arduino years and years ago, and we said, the Arduino form factor is pretty big. Why don't we do something like this? And we showed the Feather form factor, and they decided not to do it. And now their boards are gravitating towards that. In fact, when you see some of the new boards. So I think there's opportunities to work together. And I think at this point, for the open source hardware folks that are out there, it's like, well, what are we all gravitating towards? It's like, well, there's a Stemma quick type connector. There's
standardized shapes, and this, thankfully we all agree on the same battery. I mean, I think that was a quick one that we all agreed on is the polarity and pinout for LiPo batteries, which we have on the Feather boards, and the Circuit Playground Bluefruit. So that's really good.
All right, yeah. Focus on love Stemma QT. Even breadboarding can be challenging when trying to get something running quickly. We use as much Stemma QT as I can in classes. Thanks so much for a strong commitment to this platform. Other folks, just like across the board, they're using it in all the good ways.
Yeah, and it's like I didn't invent. By the way, I didn't invent the Stemma QT quick format that came from SparkFun. They did an excellent job. And I think it's cool that we can look at each other and say. And I looked at it at first. I was like, I don't know. I feel about this is it a good idea? Do people want connectors, or do they want to solder it? And then I sort of, after I started playing with it a little bit, I was like, what, this has to be the future. As I was sort of experimenting with larger JST connectors like Grove, but I was quickly kind of won over. And I think that's a good thing. It means that the people who are using, it's like, I think if you can get 2 or 3 companies to agree and their customers to agree on something, I think that's really healthy. It means that we're working together as a team, even though we are independently coming up with these ideas. And I think CircuitPython, this is like, I'm talking about one thing, but I'm talking about another thing. CircuitPython and Python hardware is the same. There's some people who are like, I don't like CircuitPython, I like MacroPython. People are like, I don't like MacroPython, I like CircuitPython. People are like, I like Python 3, I like Python 2. But we're all agreeing on the same idea overall, which is we have to get away from the software getting too complicated and difficult to debug without having interpreted languages. Beginners cannot approach C or C++ as their first language. They have to have something interpreted. And so I think it's neat that CircuitPython is so welcoming of all these different boards and all these different configurations. We take PRs all the time. People can get put into this system. Like,
here's a feather.
Unexpected Maker has feathers. Pimeroni has a bunch of boards. 2040. Yeah. Arduino has boards.
Actually, the other thing with CircuitPython, because we have HID support, you do keyboard stuff, that allows products like the Keybow to get out there. They didn't have to develop all of that.
I was, some of the things I feel like I learned a lot from Arduino. I've been doing Arduino for 15 years. And so when we started drafting things like APIs and formats and interfaces and workflows for CircuitPython, I thought of all the things that really drove me kind of batty with Arduino, like not having mass storage. Like, I'd always wanted mass storage support, native mass storage support in Arduino, and it still doesn't. I mean, we have it in TV-USB, but it pretty much, it doesn't exist as a first class capability, but HID does. And I've always wanted ways to play like audio or to handle displays in the background, to have error codes appear on a display, like all these little things that really, either I really liked about Arduino, like I like the library manager in Arduino, so we came up with like Bundlefly. Yeah. I like
cat-shaped boards.
I like cat-shaped boards. So that's kind of where it came from. It's a little bit of an evolution, but also we made some strict decisions along the way. And I think some of those strict decisions, although people would argue like, okay, you're being so strict about this, why are you requiring USB native? Why can't you just make it work with ESP32? And the answer is, we tried that and it just was terrible for everybody. Anyways, let's go back to the top and we can, we want to scroll through some.
Yeah, I wanted to show some of these just to show like this is, and a lot of these are new. They've just been added. That's why, you don't see them hitting up the charts.
Yeah,
it's sort of by
it's
downloads
like a dev
right
board,
now,
or it just doesn't exist or something. So it's not very popular.
And so,
all right, so let's keep going. We'll go through them pretty fast because we're
still rocking.
So we've got the Feather M0 Express, a Quie Pie RP2040. This was fun. We did a couple RP2040 boards, and I really wanted one that had a Stemma QT connector. So, we got that happening. The Wio terminal from Seed is kind of neat. It's sort of like a Pi portal, but like all in one, and has a case and a display. Display support in CircuitPython is first class. The REPL appears on it. This is something that when we developed the Pi portal, that's when which was our first display built-in board. Scott was like, well, I really want to have the REPL appear on the TFT. And I have to admit, I was sort of like not convinced by that. I was like, well, is that useful? Why is that useful? But actually, once we had it, I'm like, oh my God, this is really useful, because if there's an error, it displays on on the TFT. While you're debugging, you can see what's happening on the REPL on the display, so you don't have to be tethered. Whereas with Arduino, a lot of times if people are like, it's not working, I say, okay, plug it in and then open up the IDE and open up the serial monitor. But what if the serial monitor output appeared on the display? So I think having display native has been interesting, and it's really, really, really hard to do. Like, it's a major lift. It's very challenging to have that native.
Also remember with MagTag, because E-Ink, just like parallel. Ink was really hard to do on Arduino, and now you can just drag and drop images, and you can get stuff
like
going.
having it dither for you automatically. There's a lot of little things like the fonts management. These things that are so
devices
hard
normally look terrible.
They're they have to transform them, and you have to convert them, and you need like a coprocessor. So we have a lot of I know people are like display IO is a little bit weird. It's not the same as most because it's object and layer oriented, not raster oriented. You can do raster graphics, but it's like we did for the turtle demo, but it's different. But I think it's very powerful. And if you're doing user interfaces where you want updates and you want to have smooth animation, I think it's a worthwhile trade-off. So the Clue is also another board, microbit shaped. This was another AdaBox board that was designed. It was ironic. We have some in stock, but believe me, this board contains absolutely every single thing that you cannot get anymore. It's like what chips are unavailable? All of these, like nothing on here can be purchased right now. So I don't even know. I think I probably have to redesign this board actually once we run out.
Guess we could do an RP2040 version or something.
I did design RP, but the sensors are what I can't get. Every sensor on there's a lot of ST sensors and they're all unavailable. It's really it's quite frustrating. Only the APDS I think I can get. The accelerometers and gyros are totally gone.
All right. Well, speaking of display IO and IoT and all the stuff that's hard. So the Pi Portal, I think it was when we released it, and I think it still is. It's the lowest cost, easiest to use IoT display. It's
designed for IoT. We made it so easy to do IoT projects. We had a big burst of projects of like, okay, I just want to display something from the internet. And what's fast, and do it with a nice font, right?
And beautiful graphics.
And this is so hard to do in Arduino.
You want to do a Star Trek interface? No problem.
Yeah. I have to redesign this because, again, I can't get the 7050 ones. We have a few in stock, but I'm going to redesign this to be, ESP32 S2 only. And it won't be as fast, but I think it'll be worth it. Also, the S3 will come out, it'll be dual core, and then we can do, maybe Wi-Fi and graphics on one core and then main core for computation.
And one thing that someone just mentioned in the chat is they said they appreciate the fact that CircuitPython can be put on my own custom non-commercial board. Support for new CircuitPython releases is automatic. That's right.
Yeah.
As soon as you add it to here, which anyone can do, anytime there's updates with CircuitPython, you get it. And so like Unexpected Maker, Arturo and a few others, they've said publicly like, oh, every time there's a new CircuitPython release, I get new features.
Yeah, and we're never going to require people to pay or do something, financial or residual for getting boards included into CircuitPython. You do a PR. The only thing we require is a unique PID, and the reason we do that is because we do and have had detection based, what board is plugged in. Eventually, once we start doing more serious, like IDE tied firmware update notification, knowing what board it is like very helpful. If people are all sharing the same VID, PID, we can't tell what hardware is attached because there's no other unique identifier. But we can get people VID, PIDs, RP2040 and Espressif. They do. If you're using their chips, they'll grant you one. Microchip has a granting program, and then the open PIDs also you can get one. So it hasn't stopped anybody. It's just you have to have a unique identifier, but that's it. And those are free. So you can any board you want, even if you made one just for yourself. You made like a small run of DEF CON badges. Do the PR, and we'll get it in, and it will be part of the release. You will forever have firmware available for you that is as up to date as possible. You'll get all bug fixes.
Yeah.
You don't have to do your own builds for you.
Here's a comment from someone. I'm trying to learn how to add CircuitPython to my custom 2040 board. I love how open CircuitPython is. That's right. We've gone a completely different way because we saw hardware kind of getting more closed source. Like, like this isn't really open anymore. You have to use it with this IDE. You have to use this board. And we're like,
we're starting to see
let's
that
go the other way. Let's be
like,
more open than everyone else.
You can't be included in this IDE, or the IDE requires, you know, a licensing fee, which is fine. But we wanted to.
Yeah, that's now covered.
That's covered.
That style of electronics covered. What isn't covered is having any IDE you want to use. Having the board files.
And that's another thing.
And having under open source license.
What I like about having just a CDC REPL and a text file on a file system is you can literally use any IDE. People are like, but I want my favorite. I'm like, you can use it. And they're like, but what about, yep, it's fine. Anything that can save the file onto the file system, you know, ideally one that writes the entire file at once. We have a little FAQ section about it, just because that makes it flushes to the file system in case you unplug it. You don't want to accidentally frazzle it. But I think that, you know, I use Atom. I really like Atom because I have this nice plugin with the REPL. Yeah. Some people use VS Code. I think Moo is a great beginner.
Yeah. I use Moo, and now I'm getting back over to VS Code because there's a lot of stuff for it, and a lot of people use it, and it's hooked up to a lot of things.
VS Code just feels heavy to me. I like Atom. It's, you know, I like something fast. You know, I still use XEmax, but Atom is for me. I think that, you know, my go. And what's neat is that, any IDE you want to use. And some people don't even use the IDE. They use Screen or Minicom and VI. And God bless. You can do that. Nothing's stopping you.
And so as we go through these, I wanted to also point out, like, so we have a Screen thing. We have an e-ink thing. We have a Wi-Fi thing. We also have, if you wanted to develop a handheld game, there is a open source board out there. And it happens to run, you know, CircuitPython. And you can also run other things on it. And
I like it when our chips can run our boards can run multiple programming languages, so that, you know, the SAMD51 has excellent support in MakeCode arcade, so you can write arcade games in MakeCode, and like, it's amazing. You can write games like this, you know, all drag and drop, super easy. And then, you know, I ported a Nintendo emulator to this chip as well.
Yeah. So, you know, when you have a checkbox of like, well, I want a gaming thing. Okay, well, I want a costuming thing. No problem. I think this is like, I think one day we're going to look back and say, like,
this is actually one of the few boards that's really, CircuitPython does not work very well with it because it doesn't support both eyes.
Yeah.
But you could use it if you wanted to.
You know, it's such a unique board that we wanted to have for costuming. So you could still do stuff on it. And you can even split apart the eyes.
Yeah.
That's a neat feature of it, is these can come apart and then you can connect them with cables.
Yeah. Kind of ridiculous that we did this for an AdaBox one year.
We did this for an AdaBox
2 years ago.
Yeah.
But we really wanted to do digital. We had done the Halloween, and then
this is a monster.
Oh yeah. Once this again, the SAMD51 series, I love it. And one of the nice things is that they have a chip with 144 pins, which meant we could do finally a mega shaped board with tons of GPIO pins. And people, it's not the most popular, you know, board we have, but
it's out of stock.
Some people, because it's really hard to get these chips. So yeah, I think, you know, check if DigiKey has them in stock. They might have a few. But the Grand Central, you know, just near infinite GPIO, right? So you're rocking out if you want to, if you want something very fast that runs CircuitPython very, very well, has built-in, you know, SD card and all that.
Also, just a little note, Toddbot's in the chat. Check out Toddbot's, maybe the link that's in Discord. Even the Funhouse can be a really good game development platform. He's doing some cool stuff with asteroids.
Cool. Yeah, I mean the graphics management system and tile map in Display.io is quite powerful. It's great for games. It's a little unusual if you've never programmed in it before, because a lot of people who've done microcontroller programming are used to rastering everything instead of treating things like objects. But the nice thing is you get flicker-free animation, which you can't. It's very hard to do in Arduino.
And then you know, we made a bigger version. This is, you know, PyPortal with a bigger screen.
Yeah.
And you know, also out of stock because of the
can't get the SAMD51s.
Can't get the what?
Let's go back.
Yeah. And also wanted to mention we have NeoTrellis. This is another interesting. I feel like we're we have this whole menagerie of boards.
Yeah, this one I just wanted one with like buttons, like a little audio play thing with a 4x8.
Yeah, made
matrix.
soundboards with it.
Yeah, at the time we had a couple developers who were really into music and interfaces. So we're like, well, what if we made a little handheld?
It has an accelerometer, and you can use that to like bend the sounds. Like this is like a really interesting, weird board. We have some in stock right now too.
We do. Some things are available. Actually, I think the Pi Portal, the reason we can't get screens either. There's a screen shortage as well. So we got a bunch of boards from Pimoroni. So historically, Pimoroni hasn't made a lot of development boards for microcontrollers. They've done like sensors and Pi add-ons, but with the RP2040, coming from Raspberry Pi, they've started doing a lot more microcontroller boards. And CircuitPython is great. Pimoroni especially really likes arcade and keyboard type things. They're really into that stuff. And it's a really good match for CircuitPython because, again, we got native HID support, native keyboard support in CircuitPython. TinyUSB has made that possible thanks to TAC, our developer who, started TinyUSB actually privately, while working at Adafruit, I think, or maybe a little bit before. And so we've sort of brought TinyUSB into mainline Adafruit supported open source software. And it's what was amazing is, after Scott got the first builds of like, okay, I've got CircuitPython booted up and I've got like, the USB CDC working. I went in, I turned on HID and compiled, a version with HID, and I'm like, it just worked. And I, turned on MIDI and it just worked. Having a shared USB stack that almost all of our boards use, not all of them. The SAMD21, I think, still uses its own stack because it's very tuned to its own thing. But the RP2040 uses TinyUSB. The SAMD51 uses TinyUSB. NR52840 uses TinyUSB. The IMX boards also. It's a really it's a keystone part of the CircuitPython experience to have this shared USB peripheral, because USB is so hard and annoying to implement. And every single company historically has had their own USB stack that was licensed to only be used by their chipsets. And so you would you'd get an ST board and they'd be like, here's the ST stack. And it would say like, you can never use any of this with any other chip from ST. And so like you have this ultra fragmentation of USB support, which really, I think, held back firmware development.
That's an example of, we were talking about Stemma and Quick. So we added that on the boards, and a lot of people can do more. There was nothing that covered USB across multiple chips, and now we have
because there's nobody had any incentive to do it.
Yeah, it's like, why would you do all that work for all those other
chips? Every company was like, we'll do basically 80% of the work and make sure that nobody else can use it.
So what I'm trying to say is, for the folks that especially if you're chatty on like social media, we make a lot of decisions that aren't great for Adafruit, but it's great for everyone out there in the community. And I think long term it's good for Adafruit, but supporting us by purchasing something once in a while will allow us to keep making a USB functionality across multiple processors.
Yeah.
Like that, like we did it.
Yay.
So
all right, let's cover a couple more, but then we'll bounce back because we're gonna run out of stuff. So
we got like 10 minutes or so.
Well, I wanted to I wanted to also look at Blinka as well.
You want to look at Blinka? Okay.
Yeah. So so we got a couple, we got a lot of more boards. We have a couple STM boards. As we get to here, it becomes less not less popular, but these are.
I'll mention this. So we also have like another round. We want to keep doing low cost, easy to use, and we also have Trinkies. So there's a lot of Trinkies that are either in development or Trinkies that are available right now. And just to get ahead of it, like we're gonna have limited edition ones. We're calling them not forever Trinkies, but it's nothing to do with NFTs.
Yeah.
Nothing to do with NFTs.
They're just limited Trinkies.
They're limited edition Trinkies. And so we want to do stuff like that. But then we also have these characters, but we wanted to have something like fun. Like this just shows up as a drive and then you could do anything with it. And it's like $6.
Yeah.
So lots of fun.
Okay.
All right. What else do you want to show?
Nothing. I think a lot of these, as we're getting down here, a lot of these are like, people
more keyboards
doing individual, people's projects. People come up with their own private boards, or Thea Flowers doing synthesizers, and this is it's not a CircuitPython board that's a synthesizer. It's a synthesizer that happens to be running CircuitPython. So this is actually like a finished product that's being sold that runs CircuitPython, which is neat. And so I like seeing that. I like seeing that CircuitPython can be a shipped product. It's reliable. It's dependable. It's usable.
That was another thing in the early days of CircuitPython. When I started seeing artists use it, so they would put a display in something and they'd wanted to do something on the internet, and they started using CircuitPython. It's like, oh, if artists are doing it, just like artists picked up processing and then processing led to Arduino. It reminds me of that. It's like, oh, like you're adding more people that can do more stuff with technology.
Okay.
And then you want to talk about, I think, since cat's out of the bag, as they say,
Yeah.
Our latest board was the MacroPad RP2040. It was an ADA box, and it is one of my favorites already.
Yes, we've actually been making a lot of them, but they've been selling out very fast. So this is one of the few things where we will be making more. So do sign up, because we're going to be making a whole batch of them next week. And if you got ADA box, then congratulations.
It's a good idea to get an ADA box.
You already got one of these. You don't have to wait. And one of the benefits of getting an ADA box is you're guaranteed a box.
Yeah.
That's what we should call it, guarantee a box.
Guarantee a box.
All right, how about we go to Blinka for a few minutes, and then we'll...
Yeah, so do check this out. This is, there's also an ebook reader. There's a lot of stuff. And then satellites, of course. We could spend days on everything. But the filters are your friends here.
Yeah.
And it's one of the features. I think I might make a video later where it's like, what do you want? Arduino Shield compatibility, battery charging, Bluetooth, breadboard, display, Feather compatible, GPS, LoRa, robotics, solder-free, speakers, Stemma, and like we had to make sure we were really concise with this because the topics can go forever. But then you see the list of all the makers, and there's a lot of independent makers.
Yeah, and there's a lot of makers. So you know, if you do a PR into CircuitPython.org, you know, get your build working, and then submit a PR here. You can be featured as a maker. And
this is some of the newest ones that were just added.
Yeah.
So you can sort by that as well. Okay, so Blinka is something that's a little different than...
Well, they're still boards, and that's why I thought it was, you know, I think it's
a little different, though.
It's worth talking about. So I will say these are not sorted by popularity, because there's actually no real way for us. It's not a downloadable thing like here where you download a file. But Blinka is a compatibility layer for our CircuitPython libraries that let you run it on, for the most part, either single board Linux computers or USB to GPIO type adapters. And the reason that this is interesting for me is, you know, we have a lot of people who use microcontroller boards, but there's also like half of the community uses single board Linux computers. And people want the same accelerometer to work with an Arduino or the microcontroller board or RP2040 or Pico as they do with a BeagleBone or Raspberry Pi. And what I really, 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 really wanted to do, and you can watch my, I think 2020 Linux Australia keynote talk. I teach the entire history of microcontrollers and the reasoning behind this. Really did not want to have a separate library that we'd have to maintain for CircuitPython or MicroPython and native Python. It's just too much. It's just too much work to have to support.
Reminds me of teeny USB. Why support? Why? If you could do one thing and support all the chips.
Yeah, because you have a bug in one, and suddenly you have to backport it. It's a massive amount of work, and we're already overwhelmed with the number of libraries that we maintain and manage. And we're happy to do it, but you know, anything to make it easier. And so one of the things that when we were designing the APIs for hardware interfacing in CircuitPython is, at the same time, I was thinking very, very hard about how can I make sure that this will also be able to run on single board Linux computers like the NanoPi or the Odroid or the Orange Pi or the Pines or
Raspberry Pi,
Raspberry Pi 400, or the Raspberry Pi 400 and the compute modules and all that good stuff. Also explain why there's the Picos in here too, because you're like, what's not Linux?
Why is Pico there?
So, you know, thankfully Blinka has really worked out. It's been very easy for us to. I know it's one of the. It has a little bit of that tragic, like, oh, here's a standard. The 18 standards. Let's make a new one, and now you're 19 standards. But all of the libraries, pretty much every single one of the libraries that we've written, you know, especially for I2C and GPIO and SPI devices, works flawlessly on single board Linux computers or with devices like the FTDI FT232H or MCP2221 or the Pico, which can act as a USB to GPIO converter. You can put firmware on it to make it do that. And I think it's good because Python should be Python. And one of the decisions we've made with CircuitPython, which I think was a wise one, is requiring CircuitPython hardware API and code API, that the libraries we use, the built-ins we use, the modules we use, to be a strict subset of Python 3. That's not true for MicroPython. There's a lot of things that MicroPython does that you couldn't copy and paste that code and have it run on a Linux computer or on a desktop. And our goal, and if you look at the again, the Linux Australia talk that I did in 2020, is I have this little thing called I think it was like temperature sensor 3 ways, duck 3 ways. And I show, here's the same exact code, like literally copy and paste code running on a Windows computer, connecting to a sensor via FT232H, on a Raspberry Pi Pico, wired up to the sensor running CircuitPython, or a Raspberry Pi single board Linux computer connected to the GPIO. Same code running on all 3 platforms, the exact same output, this exact same experience, flawlessly.
Yeah.
And I don't believe in write once, run many, right? I think it's a bit of a lie. But I did want to minimize as much as possible the frustration of having Python feel different on CircuitPython boards versus single board Linux computers or desktop computers. And what's really neat is that for development, this is really fun, because when I write CircuitPython libraries, I use one of these. I don't even connect it to, I write it on my desktop computer, and I use this to connect to I2C, because I know that if I can run it on CPython on my Windows machine, that same code, then I move it over to a SAMD21 or 51 or Pico or Raspberry Pi. It just works. It's like very, very, very good. And it means that we're able to do more hardware because it's the software that takes so much effort.
Learn once, have fun everywhere. I feel like that's the thing. It's like, once you start playing around with some of these things, your knowledge is portable, which isn't always true.
Yeah.
With technology and certainly electronics.
All right.
So that's Blinka.
So let's see if there's any questions.
Yeah. Well, I was trying to knock them out before, as they were coming in. But let me see if there's anyone can ask anything before we wrap up. I do want to point out that we have a code.
There's a code.
I didn't tell anyone. I just wanted, this is just for people. I'm going to turn it off in a few minutes. The code is board tour, and you can use that for anything that's in stock in the Adafruit store, which, things could,
it changes. Yeah. We do have a lot of stuff in stock. I'll say that it's been an exciting challenge every day to get chips, but we're designing around it as much as possible. But we do have Picos in stock, I think.
Yeah, we have a Max 3 per customer.
I think we can remove that soon because we actually finally have enough.
But we just put in a bunch of stuff right now. Check out all the. I did want to mention one thing with this pack. So the MacroPad, because it's hidden, because it's like underneath the PCBs, you can see the silk art.
Yeah.
Has nothing to do with CircuitPython. I just want to point that out.
Okay.
And so let me just see if there's anything else that came in, and I think we're going to be right on time. Okay, here we go. Any new or upcoming CircuitPython capable microcontrollers you're excited about, or in stock ones you've recently discovered that look cool?
I'm super excited for the ESP32 S3 because it adds back, I believe it adds back Bluetooth Low Energy, and it has dual core. And hopefully it's going to have almost identical implementation as the S2, and so that'll be like a powerful Wi-Fi and Bluetooth Low Energy capable board with native USB. I think it's going to be a really great Wi-Fi chip. I'm looking forward to getting those IMX boards I designed out. I was about to release it and then got hit with this massive shortage, but I think those chips are finally available again. So we can make some IMX boards. Those are very powerful.
Yeah.
It's fun to run CircuitPython at 500 megahertz because you're just like, it feels so snappy.
It's a glimpse of the future.
It's very enjoyable. Obviously every chip is going to. Chips are only getting faster and faster. ESP32s are running at 240 megahertz. The SAMD 51s are 120. The RP2040s are 133. So the chips are getting faster and faster. I don't have any other insights though. Those are the only chips that I know about. I would have really loved, the only chip that is like a fantasy chip for me is the SAMD 71, which doesn't exist. It's a fantasy. But basically something that's a cross between IMX RT 1060 capabilities, but a SAMD 51 peripheral set and ease of use, like a lot more RAM running at 450 megahertz. Maybe something that could even run Linux a little bit. That would have been a great chip. Doesn't exist though, only in my head.
Also, folks were just mentioning in this chat, and I just put in there, the code won't end at 5. I'll let it go a little bit longer.
Yeah, we're just,
Yeah. Okay.
But Diane, don't email us tomorrow when it doesn't work tomorrow. It's not gonna.
Okay.
We're not gonna leave it on that one.
PIO, please, on all future chips.
Yeah, Scott likes PIO. PIO is very cool.
Is WowKey on your radar? It's really great. WOWKI.
I have no idea what that is. I don't know if that's a
from
chip.
Ham Labs. USB host would be great. It's a request.
Yeah, I think devices that have. It's some fandom thing.
It's a wiki dedicated to cataloging the Warcraft universe.
Okay. I don't think that's.
I don't think CircuitPy runs on it. I have one just because it comes up every CircuitPython day.
Yeah.
Maybe someone like Sci-Fi doing a RISC-V.
I think a RISC-V chip would be cool
with USB.
I would love to do a RISC-V. I think that would be neat, but right now there's just no good. There's no good chips at this time.
Okay.
All right.
I think. Well, things are moving forward. You might have seen that. Yeah. Okay. Maybe. All right. That is.
All right. Thanks, everybody. It's
everything. We're right on time. Thanks so much
for joining us.
Yeah. Today has been CircuitPython Day. Thanks for joining us. We did the board tour. We'll be able to get this out to people who are like, I just want to see all the boards and like all the different things and why you did this stuff and what is Blinka, all that. So that's why we want to do that today. And definitely check out the Make board guide
Blinka.
that Make did with DigiKey together.
Yeah.
And then check out circuitpython.org/downloads. CircuitPython.org, of course, CircuitPython.org/Blinka. And special thanks to everyone hanging out behind the scenes and more. Let's see, Mr. Certainty was in all the various chats. Thank you. Scott was over there, and I think a lot of our team was as well. We very much appreciate we were able to take a little bit of a break from the factory. We are going to go back to work now.
Okay, thanks, everybody.
The next one up is 5 p.m. with Scott, Deep Dive, streaming in 1 hour.
I wonder what it's going to do. I have no idea.
Talk about CircuitPython.
I mean, yes, but. All right, bye, everybody.
All right, bye.